One area that we saw for the future of agricultural IoT is digital twins. In the idea of digital twins, there will be a digital replica for physical objects. So in the case of agriculture, what this could look like is that the machinery, the fields, buildings, and the farm themselves will have a digital twin, allowing for operators to do everything from run simulations, um, to predict outcomes and to optimize their decisions. And researchers and industry are delving into this idea. One of the one of the ideas and benefits of using digital twin is that by allowing the farmer to continuously monitor the field conditions, everything from weather conditions to soil moisture level. It will allow the farmers to adjust irrigation schedules, pesticide use, fertilization use, and optimize for their resource usage. Once you once a farmer establishes a digital twin, a digital representation, it will allow them to run simulations. It will allow them to do everything from change the different weather patterns to the soil conditions, the pest pop, pest population, and this way the farmer can evaluate what the impacts of these conditions are and see what would happen if these changes and deviations happen in real life. Um, and that way the farmers can have a customized plan for their specific farm in a even in a small area in a small geography. The areas can be different. There can be microclimates, there can be geographical features that affect an area. So this will allow farmers to have a customized plan for a specific part of the farm instead of having a uniform plan for the entire farm. Then lastly, there's the idea of cloud, fog, and edge computing. And it goes hand in hand in with digital twins because one enables the other. With with digital twins, you can optimize. You can optimize when you have a remote and a labor constrained farm. You can do things like, okay, here there's poor network connectivity, so are we going to do edge computing or cloud computer? Maybe edge computing because you don't have that network coverage that you need for cloud computing. And with proper design, you can have other benefits such as reducing latency and the need to transmit a large amount of data. Again, that in the example of doing edge computing. Or maybe vice versa. Maybe you do want to send that data outside because you're limited in the devices that you have out in the field, or maybe you want to send it offsite for research and policy making. The next idea is the thought of improving data processing. With smart agriculture, you're going to have a large amount of data coming from a range of devices, and the data being of a range of different types. And the data has to be quickly handled and processed in real time to identify trends and also flag and even possibly resolve any possible issues. Researchers are proposing ways to be able to do this, to quickly if and efficiently process data in real time. And one of the proposals they have is to improve the routing of the data itself. And if you improve the routing, it will reduce the latency, improve network energy usage, and make a more efficient use of the resources out in the field. And one idea specifically is to use software-defined networks. And in this case, SD software-defined networks, SDN, are are the concept of using network architecture that's driven by software versus the traditional route of or the traditional networks that were defined more by their hardware. And within SDNs, researchers are proposing the use of machine learning. Machine learning is good at identifying trends in large amount of data, in a large data set, such as the large amount of data that is produced by smart agriculture and IoT. And the idea or the proposal is for these AI and ML algorithms to tag and dynamically route the data. Other researchers are proposing other routing protocols, not necessarily using AI and ML, but with the specific goal of lowering energy usage and increasing network lifetime. You can imagine this will be important in agricultural IoT. On a farm. You may have many devices over a wide area. If you have higher energy usage across many devices, it will become burdensome for the farmer. And if you have low network lifetime, it will also be burdensome for the farmer. They will have to go out to the field, find devices, replace them, constantly maintain the sensor system, or their IoT system will malfunction. L- Moving on, there's one big area we notice in the future of IoT is the relationship with climate change. With the world population continuing to grow, depending on a finite amount of land and resources, there is, of course, climate change for negatively affecting the planet. And these changes make farming worse or more difficult. There's the extreme weather affects crop yield. It degrades the available land. It decreases the amount of water available. And farming in turn aggravates climate change. It or degradation more in general. There's an increased need of using chemicals to ensure yields. There's the competition for suitable land, for water resources for farming. But with IoT, farming can be improved. Everything from improved in crop yield to help or and also make farms more efficient and decrease resource usage, decrease their footprint, and decrease their impact. So one of the ideas we identified is the use of IoT and sensor systems and IoT to deal with crop disease. With climate change, there's more extreme variations of weather. This stresses crops. Stressed crops become more vulnerable to disease and pests. Research is proposing, or researchers have already proposed, not just researchers, practitioners too have already proposed using IoT and sensors and machine learning to help predict and prevent and treat um, crop disease and pests. But researchers are also considering how complicated this will all be. With the graphic on your here on the screen, you can see the range of data, the range of sensors. Consider the range of sensors and the range of AI and ML to process that data. Now consider the dozens of crops that humans grow throughout the planet, and consider the dozens of diseases that and pests that affect that crop or those crops. So researchers are understanding this is a high burden trying to deal with all these different permutations of what is possible. And one of the big recommendations they're highlighting is the need for stakeholder collaboration across practitioners, researchers, academia, um, farmers, policymakers, etc., and also an increase in the sharing of data to help lighten the burden of trying to come up with solutions for all these different cases. Next is the is crop yield algorithms. Here, researchers are proposing it at two levels. One is the local level of, hey, do you have farmers with sensors out in the fields? Uh, use developing better algorithms that consider climate change will help them better predict yield. But now, if you aggregate that at a regional and at a national level, then policymakers can help plan for things that affect a range of issues from agricultural policy to employment to food security. So In summary, upgrading uh, these yield algorithms will help just gives both farmers and governments a tool to deal with the threat of climate change. Finally, we we noted that there's several pilot projects and research papers that see agricultural IoT, smart farming, etc., as a response to climate change. So one was one example was the the using of smart farming in Cyprus. Another was surveying Thai farmers to see what their sentiment was towards farming practice and climate change. And lastly was a case study in Vietnam that uses smart agriculture to improve the productivity of their coffee farms. So these were across a range of different countries, each country with its own unique unique political system, geography, climate, etc. But it's it was interesting and it was good to note that these projects were not just, hey, is IoT effective? Can Because the answer is yes, IoT can make farms more productive, but they also delved more into the psychology of, hey, let's try to get the local communities to use smart farming, smart farms, agricultural IoT, etc. Help drive that usage. And in two of these cases, they also ask the question of, hey, if you're not using it, why aren't you using it? And it's more about trying to understand why they're not using it to help bring about that change to get more people to use it. So moving on, we noticed throughout our research that there are areas for improvement both from different parties of, hey, further research is needed in this area, or further focus is needed by industry, um, So one area we notice is the need for resilient sensors. It, there's a lot has been said about how sensors and the price of technology has come down, and sensors have become inexpensive and affordable. While this is good, this could be also lead to the trade-off of them being more prone to damage. In in farms, field conditions can be extreme. It can be high humidity, high temperatures, chemical exposures, vibrations from operating machinery. So training, there should be training and solutions in place to help fix or even automatically predict um, when a sensor and a sensor network is going to fail. Next is the need for increased training. In our in our paper and our research, we've noticed so many changes in and possible combinations of technological considerations in smart farms and IoT. You can imagine farmers or the workers out in the field will now need a range of abilities and skills to deal with the farm of the future. Everything from being able to operate and repair a different or a range of different sensors, being able to interpret the data that they're collecting, ensuring the cybersecurity of these sensor systems, very important because food security is national security, and being able to adapt the sensor systems to the harsh and unique climates or environments of a farm. And if you combine this with a country with the thought of a country like the U.S. where estimates vary, but uh, there's estimates that around 70% of farm laborers are migrants. Maybe they don't necessarily have the training and experience that is needed for these future technologically advanced farms. So communities and practitioners will need to come together to ensure that that the lack of training will not hinder, well, that the lack of training will be addressed, or else the adoption of IoT will be hindered. Next is the financial considerations of smart farms. As you can imagine, it might get pricey to upgrade a traditional farm to use IoT. You have considerations, everything from network connectivity, cloud computing, the on-site devices, the processing power and expertise needed, and as I just mentioned, also the training that's needed. We or people who want smart farms are asking a lot from farmers. These will represent a high upfront cost of acquiring the devices and the training needed, but also the operational cost. Now you have the cloud computing and the technological burden of maintaining the sensor systems and so on. So we don't know what the solution is, but maybe it could look like a partnership or a financing structure to help farmers initially adopt the agricultural IoT on their farms and wait until they've realized the gains and the benefits of IoT before they start paying back that debt. And then finally, there's miscellaneous issues that were noticed. There's several papers that highlighted some of the gaps in research. There is the one identified that there's actually very little research into the cybersecurity of in smart farming. Another identified that AI is rarely used in certain parts of the agricultural value chain. Specifically, they mention food processing and storage, which is not necessarily agriculture, but is just one step removed from agriculture. There's the thought of standards as well. This is maybe understandable given that there's been rapid technological change, maybe, or there's been rapid change constantly, but also in the very recent past, think of 5G, think of large language models, think of the inexpensive drones that have come into the market. So there's been a lot of changes, and stand researchers have highlighted the lack of standards in many cases. So understandable, but still needs to be addressed as standards still need to be made. Um, and then finally, even though we did mention it in this presentation, there's still we still had a sense of a lack of focus, a lack of papers on increasing and driving global adoption of IoT. So climate change, farming practices, these are global issues. Food security, these are global issues that transcend borders, and it's not just a developing country issue. It's not just a developed country issue. This this affects this affects a wide range of countries and policy, and etc. So researchers, policymakers, industry, etc., need to focus on not just creating IoT or creating the technology and talking about how great it is, but going out in the field and talking to local communities, to those unique areas, because every community is unique, every country is unique, and trying to see what is preventing them from using IoT.